Hello, welcome to Anybody Can Learn. Today we will practice for our quiz 1. Consider a data set in R2 for a clustering problem with two clusters, k is equal to 2. The ith data point is represented as xi, yi. So these are the points: point 1 with coordinate 0, 0, point 2 with coordinate 2, 0, point 3 with coordinate 3, 1, point 4 with coordinate 5, 1. Z superscript t is equal to z1 superscript t, z2 superscript t, z3 superscript 3, z4 superscript t indicates the cluster assignment vector at the end of the time step t. Z superscript 0 indicates the initial assignment. The cluster indices are represented by 1 and 2, that is Zi superscript t belongs to the set 1, 2. Based on the above data, answer the given sub-questions. The first sub-question is, if Z of superscript 0 is equal to 1, 1, 2, 2, which of the following is the final cluster assignment after running k-means on this data set with this initial configuration? These are the options given to us. So what is a k-mean? K-mean clustering means is an algorithm that groups similar data points together. Its goal is to minimize the distance between points and their assigned cluster centers. The cluster centers is called as a centroid. So k-mean algorithm is, step A is compute the centroid and step B is assign every point to its nearest centroid. Repeat these two steps until the assignments stop changing. When nothing changes, we say that the algorithm has converged. Understand the question now. The Z superscript 0 is equal to 1, 1, 2, 2. This means these four numbers correspond to our four data points. That is, P1 belong to the cluster 1, P2 belong to cluster 1, P3 belong to cluster 2, P4 belong to cluster 2. Now visualize the data points. So P1 and P2 are in the cluster 1, P3 and P4 are in the cluster 2. Now find the centroid for each cluster. The centroid is the average of all points in a cluster, and it is calculated by the formula mu is equal to 1 upon n multiplied by summation of xi, where n is the number of the data points in that cluster and xi is the data point in that cluster. Now calculate the mu or centroid for cluster 1. Cluster 1 has 2 points 0, 0 and 2, 0. The average of x coordinate is 0 plus 2 divided by 2, that is 1, and average of y coordinate is 0 plus 0 divided by 2 is equal to 0. Therefore cluster centroid for cluster 1, that is mu1, is 1, 0. Similarly calculate the centroid for cluster 2. Cluster 2 has 2 points 3, 1 and 5, 1. The average x coordinate is 3 plus 5 divided by 2 is equal to 4, and average of y coordinate is 1 plus 1 divided by 2 is equal to 1. Therefore the centroid for cluster 2 is 4, 1. Now calculate the distance of every point from the mun. Point P1 0, 0 distance to mu1 is square root of 0 minus 1 square plus 0 minus 0 square, that is 1, and point P1 distance from mu2 is square root of 0 minus 4 square plus 0 minus 1 square, that is approximately 4.123. 1 is less than 4.123, therefore P1 stays in a cluster 1. Now calculate the distance of point P2 from the centroid. P2 is 2, 0. Its distance from the mu1 is square root of 2 minus 1 square plus 0 minus 0 square, that is 1, and P2 distance from the centroid 2 is 2 minus square root of 2 minus 4 square plus 0 minus 1 square, that is approximately equal to 2.236. Since 1 is less than 2.236, P2 stays in a cluster 1. Similarly, calculate the distance of point P3 and P4 from the centroid. P3 is a 3, 1. So its distance from a mu1 is square root of 3 minus 1 square plus 1 minus 0 square, that is approximately equal to 2.236. Point P3 from the mu2 is square root of 3 minus 4 square plus 1 minus 1 square is equal to 1. 1 is less than 2.236. Therefore, P3 stays in a cluster 2. Point P4 is 5, 1. Its distance from mu1 is square root of 5 minus 1 square plus 1 minus 0 square, approximately equal to 4.123. And point P4 from the mu2 is square root of 5 minus 4 square plus 1 minus 1 square, that is 1. 1 is less than 4.123, therefore P4 stays in a cluster 2. So even after the every point remains in the same cluster, the assignment did not changes. The algorithm has already converged. Therefore, our correct option is A, 1, 1, 2, 2. Let's summarize it. Compute the centroid for every cluster. Centroid is calculated by the formula mu is equal to 1 upon n summation of xi. Then calculate the distance of every point from the every centroid, and it is calculated by the Euclidean distance formula d is equal to square root of x1 minus x2 square plus y1 minus y2 square. Assign each point to their nearest centroid. Repeat until no assignment changes. Let x1, x2 up to xn be the IID observation from the mixture distribution. F of x given theta is equal to theta times f1 of x plus 1 minus theta times f2 of x, where theta is greater than 0 and less than 1, where f1 of x is equal to 2e raised to minus 2x and f2 of x is e raised to minus x, where x is greater than or equal to 0. The observed data points are x is a set of 0.3, 0.8, 1.5, 2.0. Assume that the initial estimate of mixing parameter is theta superscript 0 is 0.4. Based on the above data, answer the given sub-question. The first sub-question is, write the log likelihood function of the above mixture model. That is, we want to find L of theta. Now understand what is a PDF. Probability distribution. Imagine a machine that generates numbers. The rule it follows is the probability distribution. It tells us how likely is each value. Probability density function PDF use a function for continuous data. Write it as f of x. That means density evaluated at a x. Example, if f of x is equal to e raised to minus x, then f of 2 is equal to e raised to minus 2. Normal distribution. One distribution generates all the data. Example, only f of x is equal to e raised to minus x does all the works. In mixture distribution, instead of one machine, we have two machines. Machine 1 has a density f1 of x and machine 2 has a density f2 of x. They take turns generating the data. Now imagine that before generating every machine, we choose a machine randomly. So we toss a bias coin. The probability of choosing machine 1 is theta and the probability of choosing machine 2 is 1 minus theta. Sometimes data come from machine 1 and sometimes data come from machine 2. Now understand the formula. F of x given theta, calculate the overall probability density. Theta is the mixing probability. Tell us how often machine 1 is used. And 1 minus theta is the probability of using machine 2. F1 of x is the density of component 1. F2 of x is the density of component 2. For example, suppose theta is 0.6. The machine 1 is chosen 60% of the time and machine 2 is chosen 40% of the time. Overall probability becomes 60 multiplied by machine 1 plus 40% multiplied by machine 2. This is exactly what the formula says. Theta times f1 of x plus 1 minus theta times f2 of x. Now introduce to log likelihood. How likely is it that our observations were produced by this model? That probability is the likelihood. L of theta is equal to multiple of f of xi given theta from I to n. It means multiply the probability of every single observations. In our question we have 4 data points. So L of theta is equal to f of x1 multiplied by f of x2 multiplied by f of x3 multiplied by f of x4. We are given a specific densities f1 of x as a 2e raised to minus 2x and f2 of x is e raised to minus x. Now substitute this in our formula. So f of x theta is equal to theta multiplied by 2e raised to minus 2x plus 1 minus theta multiplied by e raised to minus x. So write our likelihood for our 4 independent observation. L of theta is equal to multiple from 1 to 4 theta times 2e raised to minus 2xi plus 1 minus theta e raised to minus xi. Now remember that log of AB is equal to log A plus log B. This is our logarithmic property. The multiplication turns into addition. So apply this to the likelihood function. Therefore, L of theta is equal to summation from 1 to 4 log of theta times 2e raised to minus 2xi plus 1 minus theta times e raised to minus xi. So this is our final answer. L of theta is equal to summation from 1 to 4 log of 2e theta times e raised to minus 2xi plus 1 minus theta times e raised to minus xi. Another sub question is, consider the E step of the EM algorithm. Introduce latent variable zi belongs to set 0 1 such that zi is equal to 1. If xi is generated from f1, compute the posterior responsivity. So gamma theta superscript 0, and this is our formula for our posterior responsivity. For each observation xi, write down summation from 1 to n gamma I superscript 0 as your answer. Enter the answer correct to 2 decimal places. We have already given theta superscript 0 is equal to 0.4. We have to calculate summation from 1 to 4 gamma I superscript 0. So what is the E step? E step means estimate which component probably generated each observation. The EM algorithm does not immediately say this point belongs to component 1. Instead, it says that there is a 75% chance that this point belongs to component 1. That probability is called posterior responsibility, and it is indicated by the symbol gamma I. Consider a classroom. Suppose a beautiful drawing appears on the board. There are 2 students, Rahul and Priya. Teacher asks who probably drew it. Instead of saying Rahul definitely drew it, the teachers say Rahul has 80% chance and Priya has 20% chance. that 80% chance is exactly the posterior probability. Responsibility means how responsible is component 1 for generating this observation. The most important formula of the EM algorithm is gamma I is equal to theta times f1 of xi divided by theta times f1 of xi plus 1 minus theta times f2 of xi. That is, posterior is equal to desired component divided by total probability. Now look carefully. Numerator contains only one component, but the denominator contains both the component. Now substitute the given values in this formula. Theta is 0.4, therefore 1 minus theta is equal to 0.6. f1 of x is given as 2e raised to minus 2x and f2 of x is given as e raised to minus x. Now substitute this value in our formula. So the gamma is equal to 0.4 multiplied by 2e raised to minus 2xi divided by 0.4 times 2e raised to minus 2xi plus 0.6 times e raised to minus xi. 0.4 into 2 means 0.8. So 0.8 e raised to minus 2xi divided by 0.8 e raised to minus 2xi plus 0.6 e raised to minus xi. The observed data points given are x is equal to 0.3, 0.8, 1.5 and 2.0. Now substitute this value. Now calculate gamma 1. Gamma 1 means data is 0.3. So compute the numerator. E raised to minus 2 into 0.3 means e raised to minus 0.6. So calculate the e raised to minus 0.6 is equal to 0.5488. 0.5488 multiplied by 0.8 is equal to 0.4390. Now calculate the denominator. E 0.6 into e raised to minus xi. E raised to minus 0.3 is equal to 0.7408. 0.6 into 0.7408 is equal to 0.4445. So our total denominator is 0.8835. Gamma I is equal to 0.4390 divided by 0.8835 is equal to 0.497. Now calculate gamma 2. The second observation is 0.8. So e raised to minus 2 into 0.x is equal to e raised to minus 1.6. E raised to minus 1.6 is equal to 0.2019. So multiply this with 0.8. So we get 0.1615. Now calculate the denominator. E raised to minus 0.8 is equal to 0.4493. Multiply this with 0.6. So 0.2696. Now add this with 0.8 into e raised to minus 2.2xi. So total denominator is 0.4311. So gamma 2 is 0.1615 divided by 0.4311 is equal to 0.375. Now calculate gamma 3, our third observation, that is x is equal to 1.5. So e raised to minus 2 into 1.5 is equal to e raised to minus 3. Therefore e raised to minus 3 is equal to 0.04979. Now multiply it with 0.8, so 0.03983. Now calculate the denominator. E raised to minus 1.5 is equal to 0.22313. Multiply it with 0.6. So 0.13388. So total denominator is 0.17371. Gamma 3 is equal to 0.03983 divided by 0.17371 is equal to 0.229. Now calculate the gamma 4. Our fourth observation is 2.0. E raised to minus 2 multiplied by 2.0 is equal to minus 4. So e raised to minus 4 is equal to 0.01832. Multiply it with 0.8. So 0.01466. E raised to minus 2.0 is equal to 0.13534, multiply it with 0.6, so 0.08120. So our total denominator is 0.09586. Gamma 4 is equal to 0.01466 divided by 0.09586. So answer is 0.153. So this is our summary table with all observations and their corresponding gamma. Now add all these gamma, that is responsibilities. So 0.497 plus 0.375 plus 0.229 plus 0.153 is equal to 1.254. So our correct answer is 1.254. Now classify the every observation into component 1 and component 2 using the MAP, maximum a posteriori rule. So we will use the responsibilities calculated in our previous sub questions, and we will classify them into either component 1 or component 2 using a MAP, that is a maximum a posteriori rule. MAP stand for maximum a posteriori. Suppose there are only two components, component 1 and a component 2. We need to find where the given observation goes. Why do we compare with a 0.5? Suppose gamma I is 0.90, this means component 1 is 90% and component 2 is 10%. Obviously component 1 wins because the component with the larger percentage always wins. Now suppose another scenario, Ri is equal to 0.20, then component 1 is 20% and component 2 is 80%. Now component 2 wins. The MAP is one of the most important formula for classification. We look at the probability for component 1. If it is greater than half, component 1 has a higher probability. Otherwise, the component 2 has the higher probability. The golden rule is that if gamma I is greater than 0.5, it goes to component 1. Otherwise, if gamma I is less than or equal to 0.5, then it belongs to component 2. Now see the first observation. First observation is x is equal to 0.3 and its gamma I, that is responsibility, is equal to 0.495. It is less than 0.5. Therefore, the component 2 has the large probability. Therefore, 0.3 belongs to component 2. Now look at the second observation. Second observation is 0.8 with the responsibility 0.375. It is less than 0.5. Therefore, component 2 is again win. Therefore, 0.8 belongs to component 2. Now observe the third and fourth observation. Third observation is 1.5 with responsibility 0.229. 0.229 is less than 0.5. Therefore, third observation 1.45 belongs to component 2. Fourth observation is 2.0 with responsibility 0.153. 0.153 is less than 0.5. Therefore, fourth observation 2.0 belongs to component 2. So this is our summary table. 0.3 belongs to component 2, 0.8 belongs to component 2, 1.5 belongs to component 2, 2.0 belongs to component 2. Thank you.